Welcome back. We've learned our sorting algorithms, but you might be asking yourself, Andre, I'm still kind of confused about when to use what. What about if I get asked in an interview a question about which sorting algorithm will be best if I had a user's data of 100 million names that need to be sorted? Well, let's go over some rules. 1. When should you use insertion sort? Well, insertion sort should be used with only a few items. If your input is small or items are mostly sorted, it's really, really fast. It uses very little space, and most importantly, it's really easy to implement in code. So remember this, only a few items and mostly sorted data, you should use insertion sort. What about bubble sort? To be honest, you're never going to use bubble sort. It's only really used for educational purposes as a way to teach sorting. But it's very rare that you'll find this in real life because it's just not very efficient. What about selection sort? Again, same thing with selection sort. As you can see, its numbers aren't very good, so most likely you won't be using it. Mostly it's being used as a teaching mechanism, which I did. Sorry, didn't mean to waste your time with learning selection sort, but it is important to build the foundation. What about merge sort? And this one's my favorite. Why? Well, merge sort is really, really good because of divide and conquer. We have O of n log n. It's fast, and because best, average, and worst case is always O of n log n, we always divide up the list evenly, you can always guarantee that this is going to be the case, which is not the case for most other algorithms. So if you're worried about worst case scenarios, you should use merge sort. But if you want to sort in memory on your machine and you're worried about space complexity, merge sort is going to be really expensive. It uses space complexity of O of n. However, if you had huge files that can't be sorted in memory, so you have external sorting that you need, maybe like a process outside of memory, it's suitable for external sorting, then merge sort is good because we won't care as much about space complexity then. What about quicksort? Quicksort is actually better than merge sort, right? Average case and space complexity. I mean, it has the same speed as merge sort, but less space complexity. It's probably one of the most popular sorting algorithms. But the one downside is this worst case. If you don't pick the pivot properly, you could have a really, really slow sorting. So you have to be careful. And if you're really worried about worst case, then you'd rather pick something else. Now, you might be asking yourself, Andre, what about heap sort? You haven't really talked about that. I'm going to leave resources for you so you can learn about heap sort as well. It's very similar to quicksort and merge sort, but you see here that it has a space complexity of O of 1. Isn't this better than all of the above? Well, heap sort can sort in place and doesn't have the worst case quadratic behavior that quicksort has or the memory usage that merge sort has. But on average, it's actually slower than quicksort in most cases. It's one of those things where with heap sort, unless you're really, really worried about worst case and memory, then you might use it. But most of the time, I would say you're using quicksort or merge sort. Okay, but you're saying, what about these ones down here? Bucket sort, radix sort, or radix sort, and counting sort? How come you're not talking about these ones? Why can't we just use these? They look a lot better than all the other ones, especially when it comes to time complexity. Good question. Let's talk about that in the next video.